Alright, I've got water temperature at 58, a little bit colder. I noticed something from the last test I did. I had the water temperature at 78. When I tried Hiram's trick of putting some ice in there, I think I actually increased the 2 cups by a little bit. I put 5 ice cubes in the last one to bring it down to the 60 degrees. So, bringing 2 cups of water to boil from 60 degrees was great, but it was no longer 2 cups of water if I added 5, maybe even 6 ice cubes. I don't exactly remember what it was, but to get it down to the 60 degrees that we started with last time, I added a bunch of those ice cubes and didn't remeasure after I added the ice cube. So an additional 5 to 6 ice cubes would be more than 2 cups of water, maybe closer to 2.5 cups of water. I don't know exactly how much 5 ice cubes amounts to. So we're a little bit over. With this one I did the same thing, but then remeasured, and I'm just trying to bring the temperature, obviously that's measuring the air temperature, trying to bring the temperature as close as I can to 60 degrees. Neat little trick about the ice cubes there, Hiram. I have very high temperature water here, and I don't know that I'd ever get a good starting point to stay with, and it's good that you start at the same 60 degrees all the time. So I've put some fuel in there. Don't know if I put enough. Let me look and see here where it's at. It gets about the same as where the last one was, about 1 ounce. And don't want some outside burning there, so we'll wipe that away. We'll light that and let it bloom. Keep that away from there until it's ready. We're at 60 degrees now. That's perfect. This one I actually had one hole go a little bit lower there. And the rest of them are pretty much the same height. I used Hiram's hole punch method when I did this one. Seemed to work much better. This is a very thin aluminum, so it did hole punch very easy. Again, this is a Red Bull can, 8 point something ounces. I can't remember what it was. 8.4 ounces. They are taller than the can that Hiram talked about, and they are thinner. This one weighed in at just over 6 grams. The other one was 5.4, this one was 6.2 grams. Obviously lighter, but not as sturdy. As I mentioned in the last video, this one also crushed when I tried to push it together. So there must be a bottom level of how thin of aluminum you can use, and that Red Bull cans obviously are too thin. Now last time I put one on here, these flames were not ready. It was not quite hot enough. So I'm trying to see if it's ready, and you can see the alcohol begins to boil or vaporize once it's ready there. So I can see the little boiling drops down in there. So I'm going to now place this on here, and you want to do it slow, as Hiram mentioned, because you don't want to put it out. You want to give it a chance to breathe out the sides. And it does start off slow as well, and I think it's the cold water, but not 100% sure. I don't know if Hiram had the same problem. I didn't really go back and look. The temperature rises really quick, but then kind of settles off a little bit until that fire kicks in, and then really takes off once the fire gets up and the temperature rises a little more on the fuel. And the bottom of the pan obviously has to be hot for that to happen. When I'm done with this one, I want to show you how it crushed as well. Obviously, I already crushed once, so it will crush twice as easy this time, but I just want to show you what I did and how it looked. Then I'm going to show you my third one that I made, which was this one. Out of the can I mentioned in the first video, it's a much tougher can. I wouldn't say it's a super tough can, but it's a tougher can. It still has some flex to it. I don't know if that would be a outdoors type can unless it was in some kind of container. If you kept it in your pot, it'd be perfectly fine, but this in your pack would get crushed. So you'd need to keep it in a pot of some kind so it didn't get crushed. It's not going to get crushed just by putting a pot on it. Very sturdy. I don't know that I could stand on it, but maybe. Very sturdy can. It was 10.4 grams in comparison to the other two. I think 4 grams is worth it to not have your stove be so flimsy. It just seems to me that to go with something like this and have that danger of it collapsing so easily. I mean, you can see I can do that by hand now. Once it collapses once, this is pretty much a lost cause. You can't really use this for anything anymore because of the danger of it collapsing. And you can see how flimsy this metal is. And that's 2 pieces of metal where the top and bottom are put together. It's just flimsy, flimsy, flimsy metal, not a sturdy metal. And I mentioned this was the red. So this is actually trash. I'm not going to use it anymore because it is just too flimsy to use. And actually the one I'm cooking on now will probably be trash as well because it has already collapsed once as well. So an interesting thought would be you could do that same design where you cut the top out and place it in with any size can, even a nice, what is this, 24-ounce can. So you could have a nice huge stove doing the same design where you put the inside in and just leave the top open with using that rim as a support. But right now, let's see how much longer this takes here. $2.10, $2.11, $2.12 at $6.50. So I had my little sound turned off there, sorry. But $2.12 at $6.50 seemed to boil a little faster than the last one. Could be that I had less water in this one because this one was actually a full 2 cups and the other one was 2 cups plus 6 ice cubes. Nonetheless, I want to show you before this runs out of all its fuel how hard it is to blow this out. I don't know if you can see though, it's still lit. Now, let's say we take the top off and try and blow it out. It just doesn't happen. So this one, you have to almost burn the stove completely out and not overfill it. I've still got, I don't know, 1/4 ounce of fuel in here. Maybe not even that much. So the only way I can find to put this out is to cover it with my pot that I just boiled water in. The lid's obviously not tall enough to cover it. If I had a windscreen, maybe, but just covering the top of it doesn't actually do it. You have to also cover those holes. I'm going to show you that real quick with my lid. Just covering the top of it does not finish the job because that's what we had the pot on there, obviously, so that doesn't finish the job. It's next to impossible to blow it out. So I might be able to hold it. I missed totally that time. Nonetheless, I have to let it burn down or I'm going to run out of fumes. I'm going to run out of breath just trying to blow the thing out. So I'll let it burn off. Obviously that's considered wasted fuel. So you would need to know, using a stove like this, exactly how much fuel you needed to boil, how much water you had, or you're just wasting fuel. And when you're dealing with ultralight hikers, that is very important to know. They obviously are trying to find a 6 or 7 gram stove to save weight, and every ounce of fuel you waste is weight you waste. So, nonetheless, we're burnt out. I wanted to show you one more video. I'll get that up as soon as I can on this stove. Thanks, and goodbye. I did mention that I wanted to show you how easily this crushed, and I'm going to show you that real quick here. Let me zoom in to see if I can get a better view of it when it crushes. I know this is actually not a very good test because it's already broken down one time, as you can see from the crinkles, but just the lightest weight, and it's pretty much done. So, these cans, obviously not the right can to do it with. This is a Red Bull can, and it weighed, once cut down to this size, 6.4 I think it was 6.2, 6.4, and this one weighed, I don't know why they were different so much, but this one weighed 5 point something. Maybe it was just how much I cut off. The heights were pretty close, but maybe the piece inside had less to it, or the holes drilled were a little different. Anyways, that's all I had. Just wanted to show you that one time.